So hi, Professor LaShannon, and I'm going to finish going over section 2.2 or 2-2 from our Math 107 book, starting with example 2.7 on page 61, where they gave the data. They didn't actually give the data, but they gave the graph or the frequency distribution for the ages of 50 governors in the United States. So they gave the class boundaries. I'm going to go right away and put it in. If you look on the next page, page 62, we're going to make relative frequency graphs. So we're going to need midpoints, class boundaries, and cumulative frequency. So I'm going to start with midpoints. Remember, to get midpoints, what you do is you add either class limits or class boundaries and divide by 2. So if I add 42.5 plus 47.5, I'm going to get 90 divided by 2, which is 45. So the first class midpoint is 45. And I could keep doing that, but if you notice on the class boundaries, to go from all the lower class boundaries to the next, or the upper ones to the next, you're adding 5. So to get the rest of the midpoints, I could just add 5 to the previous midpoint, and that's going to give me all of the midpoints, which I'll need for the graphs. And so now they gave us in the graph, in the table on page 61, they said there were 4 governors in the first class, 4 in the second, 11 in the third, 14 in the fourth, 9 in the 5th class, 5 in the 6th class, and 3 in the 7th class. And if we add this up, we should get our total of 50 state governors. So in order, because there are 50, in order to get our relative frequency for each of these classes, you're going to take the frequency of each class and divide by 50. And that's going to give you a decimal value, which you could also write as a percent. So if I do 4 divided by 50, put that in my calculator, I'm going to get 0.08 or 8%. Same thing here, 4 divided by 50, that gives you 0.08 or 8%. If I do 11 divided by 50, that is going to give me 0.22 or 22% for the third class relative frequency. 14 divided by 50, that's going to give me 0.28 for the relative frequency. 9 divided by 50, 0.18. 5 divided by 50 is 0.1. If you want to stick with the same number of decimal places, you can make that, put a 0 on the end. And 3 divided by 50 is going to give me 0.06. So if I add up my relative frequency, I will get 1 because everything came out evenly. Sometimes it doesn't because you rounded. You can also have made these percents and it would add up to 100%. So there's your relative frequency. We also want to find cumulative frequency. I'm going to put in a line down here. Now the way this book finds cumulative frequency is it uses class boundaries to find cumulative frequency. So they're going to say less than the first class boundary 42.5. Less than the next class boundary 47.5. Less than the next class boundary 52.5, and so on. Less than, just using the class boundaries, 57.5, less than 62.5, less than 67.5, less than 72.5, less than 77.5. Okay. So if we go back and look at the data, there was no data that was less than 42.5. So that cumulative frequency here would be 0. Less than 47.5, we have a frequency, so far we've accumulated a 4. Less than 52.5, 4 plus 4, 8. Less than 57.5, 4 plus 4 plus 11. Just accumulating here, 19. Less than 62.5, just add 14 to that, 33. Less than 67.5, we're just accumulating here, add on 9, we've got 42. Less than 72.5, adding on 5, that gives me 47. And less than 77.5, adding that last 3, we get 50. So we're going to use all of this data to make relative frequency graphs like we did earlier in the other video. And so the first graph that we're going to make is a relative frequency histogram. And let me get a new board here. So we're going to take this data, we're going to make a relative frequency histogram. Remember, a histogram is a bar graph where the bars are touching. Along the x-axis, we're going to use class boundaries. These class boundaries starting at 42.5 going to 77.5, and I don't start at 0, so I'm going to make a break here. So 42.5, 47.5, 52.5, 57.5, 62.5, 67.5, 72.5, and 77.5. And you want to say what these are, and these are ages of the state governors. So along the y-axis, and normally in a histogram, we've got frequency. Here we're going to have relative frequency. If we go up back to our relative frequency here, the highest relative frequency was 0.28 or 28%. So kind of count by what makes sense. I'm going to count by 5% or 500ths because that kind of makes sense here. And so I'm just going to count over here. 0.05, 0.10, 1500, 0.15, 20 hundredths, 25 hundredths, 30 hundredths. And again, you want to label what is the y-axis, which is relative frequency. And again, all of this is obviously more accurate with graph paper. So we're going to draw bars that touch. So from 42.5 to 47.5, we had a relative frequency of 0.08 or 8%. Bars are touching. From 47.5 to 52.5, same relative frequency, 0.08. From 52.5 to 57.5, relative frequency of 0.22 or 22%. From 57.5 to 62.5, our relative frequency was 0.28 or 28%. From 62.5 to 67.5, the relative frequency was 0.18 or 18%. From 67.5 to 72.5, the relative frequency was 0.10 or 10%. And from 72.5 to 77.5, we had a relative frequency of 0.06 or 6%. So you can see from the graph what it shows us is that the most likely thing to happen is that a state governor is aged between 57.5 and 62.5 years. But there aren't a lot of like outliers, data that's really far on one end or the other. It's fairly well distributed. Most of the data is in the middle and then tapers off on the young and the older end here. So then taking that same data, now we're going to go, and this, by the way, first graph was on page 62 at the bottom. So now we're going to do the other two graphs on the top of page 63. And we're going to make a relative frequency polygon next. And that's on the top of page 63. That's a line graph with continuous lines. You're going to use midpoints for that line graph. And so we're going to use this column we just created for midpoints for the state governor's ages. Again, I'm not starting at 0, so I'm going to put a break here. And the midpoints were 45, 50 for each class, 55, 60, 65, 70, and 75. And these were ages of governors. And along the y-axis, again, we're going to use relative frequency. But we're going to make a line graph, so we're going to use this column here. And the highest relative frequency was 0.28 or 28%. So just like before, I'm going to count by 500ths, 5%, 10%, 0.10, 15%, 20%, 0.20, 25%, 0.25, 30%, 0.30. Always put labels. This again is relative frequency. And so I'm going to draw a line graph and I'm just going to put over the midpoint, the point at the height of the relative frequency for each class. So the first class with a midpoint of 45 has a relative frequency of 0.08 or 8%. Second class has the same with a midpoint of 50, has a relative frequency of 0.08 or 8%. Next class with a midpoint of 55 has a relative frequency of 0.22 or 22%. The next class with the midpoint of 60 has a relative frequency of 0.28 or 28%. The next class with the midpoint of 65 has a relative frequency of 0.18 or 18%. That's the height of that dot. The next class with a midpoint of 70 has a relative frequency of 0.10, and the last class with a frequency of 75 has a relative frequency of 0.06 or 6%. And then I'm just going to connect those dots with straight line segments. Again, all of this is more accurate with graph paper and a ruler, and your book wants you to bring that back down to the x-axis. And that's the same general shape that we just had in the histogram. In the previous example, we just made it as a frequency polygon, as a line graph. And so one more graph we're going to do with relative frequency, and it's a relative frequency ogive. And ogive is a cumulative relative frequency in this case. It's a cumulative relative frequency graph. And so what we have to do is we have to go back to this, and we have to, we've got our cumulative frequency, then we've got to make a cumulative relative frequency column here. So if the frequency is 0, remember it was out of 50, 0 divided by 0, the cumulative relative frequency would be 0 here. 4 divided by 50 gives a cumulative relative frequency for the next one of 0.08. 8 divided by 50, we're using cumulative frequency divided by the total frequency of 50, 0.16. 19 divided by 50, 0.38. 33 divided by 50, 0.66. 42 divided by 50, 0.84. 47 divided by 50, is that 47? Divided by, they have a mistake in the book, 0.94, and then 50 divided by 50 gives you 1. There was a typo in the book on page 62. And so taking this column and class boundaries, we're going to make a relative frequency ogive to finish up here from page 61. So we're going to use class boundaries. They start at 42.5, 47.5, 52.5, 57.5, 62.5, 67.5, 72.5, and 77.5. Again, these are ages of governors. This is going to be cumulative relative frequency, which is going to go up to 1 or 100%. So I'm going to count by, just because I don't have a lot of space, by like 20%, 0.20, 0.40, 0.60 or 20 hundredths, 0.80, and 1. Okay, so at 42.5, our cumulative relative frequency was 0. So I'm just using these numbers here. And so I'm going to start at 0. The 0 is the start point. By 47.5, our cumulative relative frequency was 0.08. So that's the height of that dot. It's a line graph. By 52.5, the cumulative relative frequency was 0.16. By 57.5, the cumulative relative frequency was 0.38. By 62.5, the cumulative relative frequency was 0.66 or 66%. Oh, I skipped here, didn't I? I'm missing one. 20, 40, 60, 80, 100. There we go. Okay. 0.66. By 67.5, the cumulative relative frequency was 84%, 0.84. By 72.5, the cumulative relative relative frequency was 0.94, 94%. And finally, by the seventh and last class, by the end of that, you've got your cumulative relative frequency of 1 or 100%. And so connecting these dots with straight line segments, there you have the ogive for relative frequency.